Okay, here's the crash course. Nice and simple. Let's start with a data center. Strip away the mystery, and a data center is really just a building that does math. That's it. Rows and rows of machines, and all day long, all night long, they're doing arithmetic. Enormous amounts of it. And the math they're doing mostly looks like this. Take a big grid of numbers. Think of a spreadsheet, rows and columns, and multiply it by another grid of numbers. That's the heartbeat of almost everything modern. When you talk to an AI, when a model recognizes a face, when it predicts the next word, underneath all of it, it's grids of numbers being multiplied together, over and over. Now here's the part that gets your attention. A single one of those multiplications isn't one step. It's billions of tiny steps. And a real model doesn't do one of them. It does trillions. Every single one of those steps is a tiny sip of electricity. One sip is nothing, but trillions of sips, running around the clock, across a whole warehouse of machines, that's why your laptop gets warm doing a little of it, and that's why a data center pulls megawatts doing a lot of it. Same activity, just scaled up until it needs its own power substation. And I want to be clear about something because this matters. That work is worth doing. The medicine, the materials, the scientific discovery, the tools people are building. A huge amount of genuinely good stuff comes out of these buildings. So the goal was never to do less of it. The goal is to do it wisely. So here's the interesting question. If it takes all that electricity, is all of that electricity actually necessary? And the answer is no. A lot of it isn't. Here's why. When people first wrote the software that does this math, electricity was cheap and the jobs were small. So they optimized for other things, for speed, for getting to market first, for code that was easy to write and easy to read. Those were reasonable choices at the time. But it means the math often takes a long, winding route to the answer. Not a wrong route. It gets the right answer. Just a route with a lot of unnecessary detours built in. Detours nobody ever went back to clean up, because for years there was no reason to. Now, there's a reason to. The jobs got enormous, and the electricity got expensive and constrained. So the route it takes actually matters now. Think of it like driving across a city. There's the long way, with every light and every side street. And there's a shorter way that gets you to the exact same address. The destination is identical. You just spent less to get there. That's what LuxiEdge does. It finds shorter routes through that math, and, this is the part that makes it trustworthy, it proves the answer at the end is identical. Not close, identical. Same result, checked and verified, for less energy and less time. And it's been measured independently, not just claimed. Now, here's where it is, and what those shorter routes can mean in a few different places. On the edge. That means small machines out in the world, a drone, a robot, a sensor, something in a vehicle, that don't have a data center behind them. Out there, every bit of power and every millisecond counts, and there's often no reliable connection back to the cloud. Because this approach is lean and can run right on the device and can produce a verifiable receipt of its work on the spot, it fits places most heavy software simply can't go. Which leads straight into constrained computing. That's just a fancy phrase for not enough power, not enough chip, not enough time. Anywhere you're boxed in, by battery, by heat, by budget, doing the same math for fewer watts doesn't just save money, it makes things possible that weren't possible before. You get more capability inside the same tight box. For data centers, it's the same idea at massive scale. Their whole world is measured in megawatts and dollars per token. If the identical result comes out the other end for meaningfully less energy, that's not a nice to have, that's headroom. It's more work out of the same building, the same power, the same capital already in the ground, instead of building yet another facility. For quant research, the trading and risk world, the prize is a little different. It's exactness and repeatability. When you run a risk calculation, you need the same numbers today, tomorrow, and when a regulator asks a year from now. Deterministic math means you get bit for bit the same answer every time, with a receipt to prove it. That's gold in a world built on audit trails. And for science, genomics, physics, engineering, it's the doors that open when the same computation costs less. Cheaper math means you can run more experiments, ask bigger questions, and explore things that were simply too expensive to attempt before. Now step back and see the thread running through all of it. Edge, constrained devices, data centers, quant, science. Every one of those expands when the math is deterministic and done for fewer watts. That's not a side benefit. It's part of the fundamental equation. Compute is capital now. It's power, it's chips, it's money, and all three are constrained. So anything that gets the same answer for less energy loosens every one of those constraints at once. That's why the upside here is so large if it holds up. You're not saving a little on one task, you're relaxing the limit that sits underneath all of them. So that's the whole thing. Data centers do math. The math takes more electricity than it truly needs, for historical reasons that made sense at the time. LuxiEdge finds the shorter route and proves the answer is identical. And that same trick pays off on tiny devices, in tight corners, in giant facilities, in finance, and in science. More math for fewer watts. If you want to look closer, it's all at LuxiEdge.com. That's LuxiEdge, LuxiEdge.com.